Okay, today we will discuss about Adam-Bashforth Predictor Method. So what is Adam-Bashforth Predictor Method? So here this is also a method to find the solution of differential first order differential equation. So we will consider here first order differential equation dy over dx, which is equal to f of x and y. So this is first order differential equation. So we will integrate both sides with respect to x from xn to xn plus 1. So here step size will be h. So after integrating we will write xn to xn plus 1 y dash will be equal to with respect to x, so will be equal to xn plus 1. So f of x and y dx. So after applying integration here, so this expression simply will become y xn plus 1 xn, and this will be equal to xn plus 1 f of x y dx. So here applying upper and lower limit, so this expression will be y n plus 1, or you can write as y of xn plus 1 minus y of n is equal to integration x of n plus 1 x of n and f of x y dx. So here this minus expression will be y of n plus 1 is equal to y of n plus x of n plus 1 x of n f of x y dx. So here further we will take as substitute x is equal to xn plus sh. You can say take variable as u or s, it depends upon you. So here x is equal to, after substitution, x is equal to xn plus sh. So where x lies between two values of x, so if x is equal to xn plus sh, so dx will be equal to, this expression will be 0. So this will become, because we are integrating with derivating with respect to s, so this will become h is constant, so ds. Simply we find dx over ds. We are finding dx over dh. So dx will be equal to h ds. So our limit will be convert if x is equal to xn. This implies if x is equal to xn, so h will be equal to 0. Similarly, if x is equal to xn plus 1, so here putting x is equal to xn plus 1, so our value will be equal to, here if we put xn plus 1 is equal to xn plus sh, so this will be xn minus plus 1 minus xn will be equal to sh. So here this expression, so here we are taking derivative with respect to s, so limit will be s, so s will be equal to 0. Similarly, this expression is equal to h. We know that step size between difference between two consecutive term is equal to h. So this will be s h, h will be cancelled, so s will be equal to 1. So simply s is equal to 0 and s is equal to 1 are the limits. So our question will be converted into if we write further, so our question will be converted into the form. If I write y of n plus 1, this equation, we take equation number 1, so is will be equal to y of n plus this dx is equal to h ds, so we will write integration this xn is equal to when x is equal to xn, so s will be equal to 0 and 1. So this will become f of x, y will be equal to y dash of xn plus sh. This expression will be y dash of xn, y dash of x. So after putting x is equal to xn plus sh, so this will be equal to uh, xn plus sh, and this dx is equal to h ds, so we will write h ds. So this will become y of n plus h will become first, so this will become 0 to 1 y dash of xn plus sh ds. So after this expression we will further solve it to form our Adam-Bashforth predictor method. So if we put the value of this expression by using Newton backward difference formula, so by using Newton's backward difference formula, so this expression will be yn plus 1. Here this will be minus yn, so this will be h 0 to 1 limit, and this expression after Newton backward difference formula, so this will become y n dash plus s delta y n dash plus s plus 1. This is Newton backward formula, 2 factorial delta square y n plus s plus 1 s plus 2 over 3 factorial delta yn dash plus up to so on ds. So further simply we will open the and multiply these values, and after simplification yn plus 1 minus yn is equal to h limit 0 to 1, this will become yn dash plus s delta yn, this operator is for backward difference, so after multiplying this will be s square plus s over 2 delta square yn dash plus after multiplication these values will be converted into S3 plus 3s power 2 plus 2s, and 3 factorial will be equal to 6 delta cube y of n dash plus up to so on and ds. So simply we will take integration here, so this will become y of n minus plus 1 minus y of n, this will be equal to h. After applying formula for integration, this will be integration of 1 will be equal to s y of n dash plus integration of s will be s square over 2 delta yn plus this will be 1 over 2 integration of s to s3 over 3 plus s2 over 2 delta square y of n dash plus 1 over 6, this will become s4 over 4 plus 3s3 over 3 plus 2s2 over 2 delta 3y n dash plus up to so on and ds. So further after simplification, if we write, so this will be equal to we will take y of n plus 1 minus y of n h, this will be equal to if we write, so our limits here will be equal to 1 and 0. So after putting the limits, so our question lower limit is 0, so upper limit we will put only upper limit, so this will become s is equal to 1, so this will become yn dash plus 1 over 2 delta yn plus 1 over 2 1 over 3 plus 1 over 2 delta square yn dash plus 1 over 6 1 over 4, we are putting value of s is equal to 1, so 3 will be cancelled out with 3, so this will be equal to 1 plus 2 will be cancelled out with 2, so 1 delta 3 yn dash plus up to so on, and this will be our next expression. So after further, if we want to solve further, so this will be equal to, we will find solution of these simple numeric values. So this question will be converted into so our question is equal to yn, if we write yn plus 1 minus yn is equal to h yn dash plus 1 over 2 delta yn dash plus 1 over 2, and after simplification this expression will be equal to if we write 1 over 3 plus 1 by 2, this will be 5 over 6 multiply with 1 over 2, so this will be 5 over 12. So this expression will be equal to 5 over 12 delta square yn dash plus, further we will take this expression, this will be equal to 1 by 4 plus 2, this will be equal to 9 over 4 multiply with 1 by 6, so this will be 3 over 8. So our next term will be equal to 3 over 8, and delta cube yn dash or plus auto sum. So in our next step we will put values of delta, delta square, delta cube. We can also write this question as y of n plus 1 is equal to yn. We can solve in this way also. So plus h, we will replace this by fn 1 over 2 delta fn plus 5 over 12 delta square f of n plus 3 over 8 delta cube f of n plus up to so on. So here we will neglect all the upper terms. So this will become y of n plus 1 will be equal to yn plus h f of n plus 1 over 2 delta f of n plus 5 over 12 delta square f of n plus 3 over 8 delta cube f of n. So this will be equal to y of n plus h f of n plus 1 over 2, putting the value of this expression. So this will become f of n minus f of n minus 1. If I write, we are writing in y form, so this will be equal to y of n dash minus y of n minus 1 dash. Sorry. So further this will be 5 over 12. So putting the value of delta square f of n, this will be equal to f of n minus 2 f of n minus 1 minus f of n minus 2, sorry, plus, and this will also be so further this expression will be equal to here if we are putting delta square fn, so this will be equal to delta fn. So to check this value is correct or not, so delta f of n will be equal to f of n minus f of n minus 1. So here this will be delta f of n minus delta f of n minus 1. This will be equal to f of n minus 1 f of n minus f of n minus 1 minus this will be equal to f of n minus 1 minus f of n minus 2. This will be equal to f of n minus 2 f of n minus 1 plus f of n minus 2. So this will be plus expression. Delta square means we had to find del operator 2 times. So further this will be equal to plus 3 over 8 after putting the value of del cube f of n. This will be equal to f of n minus 3 f of n minus 1 plus 3 f of n minus 2 minus f of n minus 3. So further we will take this as we will separate fn minus 1 fn minus 2. Simply we have to learn that here this will be fn minus f of n minus 1, this will be f of n minus 2 f of n minus 1 plus f of n minus 2. In 3 this will be f of n minus 3 f of n minus 1 plus 3 f of n minus 2 minus all the values are minus but f of n minus 2 here and in this expression also are positive. So after separate if we separate, so this will be equal to yn plus h this will become f of n plus 1 over 2 f of n minus 1 over 2 f of n minus 1 plus 5 over 12 f of n minus 5 over 6 f of n minus 1 plus 5 over 12 f of n minus 2 plus 3 by 8 f of n minus 9 by 8 f of n minus 1 plus 9 by 8 f of n minus 2 minus 3 by 8 f of n minus 3. So here we will combine fn minus 1, fn minus 2 values. So this will be equal to y of n plus h. This will be fn is equal to 1, 2, 3 and 4. So we will take fn common. This will become 1 plus 1 over 2 plus 5 over 12 plus 3 over 8. These values were fn. So now we will take value of f of n minus 1. So f of n minus 1, this will be equal to f of n minus 1 and f of n minus 1. So minus common, f of n minus 1 also comes. This will become 1 over 2 plus 5 over 6 plus 8 over 9. And similarly we write f of n minus 2. F of n minus 2 will be equal to 5 over 12 and plus 9 over 8, and f of n minus 3 will be equal to minus 3 over 8 f of n minus 3. So in our next step we will solve these values. So in our next step this will be equal to f of n, and after simplification this value will be equal to, this is 1 plus 1 by 2 plus 5 by 12 plus 3 by 8. So this will be equal to 55 over 24. 55 over 24 and minus f of n minus 1. After addition this will be equal to 1 by 2 plus 5 by 6 plus 8 by, so this will be equal to 20 over 9. So simply this will be equal to, after simplification, 20 over 9 plus f of n minus 2. After addition this will become 5 over 12. 5 over 12 plus this will be equal to 9 by 8. So this will be equal to 37 over 24. 37 over 24 and minus 3 over 8 f of n minus 3. After further simplification this will be equal to y of n plus 1 is equal to y of n, and after putting these values, so this will become yn plus h over 24. If I take in common 24, so this will become 55 fn minus this will be equal to fn minus 1. So 20 divided by 9 and multiply with 24. This will be equal to 160 over 3. So this will become 53. So there is mistake. This will be equal to 59 f of n minus 1 plus 37 f of n minus 2 minus this will be equal to, if we multiply 3 by 3 by 8 with 24, so this will be equal to 9. So 9 f of n minus 3. So here if we put n is equal to greater than equal to 3. So if we take n is equal to 3, so this will be equal to y of 4 will be equal to y of 3 plus h over 24 55 f of uh, 3 minus 59 f of 2 plus 37 f of 1 minus 9 f of 0. You can also write f3 as y dash of x3 minus, or you can write it as y dash of 3 and y dash of 2, y dash of 1 and y of 0, y dash of 0. So this expression is called Adam-Bashforth Predictor Method. So in our next lecture we will discuss about Adam-Bashforth Corrector Method.